Okay, good morning, ladies, Precalculus. Maybe Will, maybe Angel, maybe Karina will see this. We're absent today. What happens we're looking at radians and degrees. Now typically, in real life, I don't know about you, but I'm really comfortable with degrees. Make a 90-degree turn, do a 180, right? Do a 360. So when Emily's doing her 360 dunk at the hoop, right? She's got to chuckle a little bit. So we understand degrees pretty well. We know a 45 is like halfway up to vertical. And we know like special right triangles, like 30, 60, 90 right triangles. And then a 45, 45, 90 right triangle. But here we're developing a whole different language with radians. And what did you remember from the video about how radians are related to angles? That a radian is found by taking a distance equal to the, well, I'll tell you, equal to the radius of a circle and wrapping it around the outside of a circle. Yes, you're nodding your head. So you remember that. So what happens that's helpful to know, just kind of a friendly fact, is that 180 degrees is equal to pi radians. So it so happens that if you divide 180 by pi, you get this number here. So we get a number that's about 57.3 degrees in a single radian. So that's something you might be able to attach to your mind a little bit, just for reference points, or a little less than 60 degrees. And so another thing that might be helpful to you is what 2 pi looks like. Well, 2 pi is just a little bit over 6.28. So in case you run across these numbers, it just gives you something to expect. Another thing that I want you to take a look at is your mode in your calculator. Here, the fourth line down, you have this line where it says radian and degrees. Your calculator can switch back and forth between radian and degrees mode. And that can be helpful to you depending on what you're trying to find out. Right now, in this class, we're sort of navigating the bridge. We're working back and forth between radians and degrees quite a bit. And on your tests, there are going to be a lot of test questions that have to do with just that type of conversion or related to it. And then for those of you going into calculus next year or whenever, that's when you just break off totally into radians. And so that's it. You have any questions about radians right now? The unit circle trigonometry song, did some of the language from the...
Is that what you want us to put our calculator in right now then?
Probably my recommendation for most of my pre-calculus students, and Emma, that was an excellent question. In fact, I'll give you credit for that question. Emma asked the question, what do I want to have your calculator in right now? For most of the time, this class, I would recommend keeping it in degrees most of the time, but being able to be ready to go back and forth depending on the situation. Okay? Excellent question. Okay. What we're going to do is I'm going to give you credit, and then I'm going to start on these ones right here. What I'm going to do is put down like the first identity of trigonometry. It's this one right here. It's 180 degrees is equivalent to pi radians. And so we use this identity for our unit conversion factor. So if we're going to take 60 degrees and convert 60 degrees into radians, what we have to do is we're going to take our 60 degrees and we're going to have to multiply it by, to cancel out the degrees here, I got to put this in the denominator. So I'm going to put 180 degrees down here in the denominator. I'm going to put pi radians here on top. Do you see that? So what it does, it really goes back to the dimensional analysis we were working with the other day, if you remember that from earlier in the week. And so degrees over degrees cancel, and what we do is we have simplified of 60 over 180, which is going to be 1/3 pi, and typically we write this, that's more conventional, is we write this as pi over 3 radians. And what happens is that RAD is a typical abbreviation for radians, but what happens is often you'll see that angle in radians just written as pi over 3. Because when you just have pi by itself, it's sort of implicitly understood by most of the convention that means radians, that many radians. Okay, questions on that one? And what's going to happen as you get more familiar with this, it's going to be kind of like the unit circle trigonometry song, that you'll know exactly, especially what those pi over 6, pi over 4, pi over 3, pi over 2, and all those things are. And this is the unit circle that the guy talked about. And have you seen me wear my unit circle trigonometry t-shirt? Sometimes? You probably have. Anyway, this is the front of my t-shirt, except my t-shirt has color on it. And so we're going to use this. I'm going to hand these out at some point to you to work with. Okay, so what I want you to do is go ahead and work through these problems here, which are going to be 10 through 12, and just get that far. And you should be able to do those pretty quickly. Can you do those?
Yes.
Or have you done them? Go ahead and do those. And these ones right here are going to be numbers that you really should have memorized as part of your trigonometry language vocabulary at some point, I hope not too long from now.
You leave it in the radians, or in pi, right? You want us to leave it in pi?
Yeah, okay, that's another question here. Okay, Emma asked the question, do we want to leave this in pi? Typically, you want to leave these in terms of pi. So for this one here, I'll take 90 times pi over 180 degrees. Degrees over cancel. And so we have 1/2 pi, or pi over 2 radians. So that's how you would do problem 10. So what you'll do is you leave them in terms of radians, or in terms of pi radians, if you have a conveniently reducible fraction. Now you might notice on problem 13 that you do not have at that point a reducible fraction, do you? Or not a neatly reducible fraction anyway. Okay, for these other ones here, you should get, for this one, 2 pi over 3 radians. Did you get that? And this one here, you should get 5 pi over 6. And this reminds me of one of my t-shirts. I don't know if you've seen me wear the t-shirt. It's this one. There are CSC 5 pi over 6 kinds of people in the world. Did you ever see that shirt I've worn? I've worn that shirt. Well, that means there are cosecant 5 pi over 6 kinds of people in the world. Of course, the answer to that is those who understand trigonometry and those who don't. How many is that? 2. Okay. That's 2 in a kind of a funky trigonometry language way of saying 2. And we're going to get to that. Okay, now we are to number 13, where we do not have a conveniently reducible fraction for that. So for problems like this, what you're going to do is it's going to be the same type of thing. We're going to go ahead and multiply by pi radians over 180 degrees, and degrees over degrees cancel. And so is this thing right here, 71.72 over 180, and that's times pi, is this going to be a very neatly reducible fraction?
No.
No, it is not. And so when you see something like that, what you do is you say, okay, well, I'm just going to multiply everything together in the calculator, and you just work it out in the calculator. But even before you press the calculator, how many radians is this going to be approximately equal to, based on what we talked about earlier today?
How many?
How many radians is this going to be approximately, even before you press the calculator button?
Yeah, like 1.5 maybe.
At least one.
Yeah, at least 1.5. And I'll tell you, 1.5 is what the estimate from Chloe was in during fifth period. So let's go ahead and do that.
Because 60 is barely over 1, and that's
So
1.
60 is barely over 1, right?
Yeah.
So it's going to be more than that. So 71, is it 71.72
Yes.
times pi sobre 180. Oops, if I go ahead and press the right buttons on my calculator, that'd be nice. There you go, 1.25. So not quite 1.5, but in sort of in the ballpark. So 1.252 maybe, if we go to the thousandths place. So 1.252 radians. Now, in this case, when you don't have pi associated with it, it's especially important that you label the units radians, because otherwise you might think if it's an angle that it might be 1.252 degrees. Is there a big difference between 1.252 degrees and 1.252 radians? Yeah, okay, a factor of 57.3, much of a difference, right? So just look for that. So what I want you to do is go ahead and work on these problems. Okay, 14, 15, and 16 are all quite similar. So go ahead and work those out, and I'll choose people to give me answers for those. How's that? For 14, 15, and 16. You have your calculators, everybody? Yeah, you got your calculator? So I'll just call on you and give you credit for giving me answers on this here. 14. Who's going to give me an answer for this one? It's going to be Emma. What'd you get for this one, Emma?
0.206.
0.206. So Emma gets, here it is. So 0.206 radians. And did you put the RAD on that, Emma?
Yes.
Very good, good work. Okay. Call on people to help me out with 15 and 16 quickly too. One more start. Okay, number 15. Kinsey, all right. 1.069. And what are the units? Radians, right? Okay, how did I know that Kinsey's answer was a reasonable answer?
Because 60 is 1.
Because 60 is a little over 1, right?
Yeah.
So this is gonna, so 61.24 is gonna be a little over 1. Right? Thank you, Kinsey. By the way, as far as the videos go, I gave a text message to Kayla's mom last night. What was in that message? Have her watch the videos. Is she gonna watch the videos?
No.
We'll see.
Shame.
She'll look at the answers.
Here we go. Now the next one. This next one will be Hannah. All right, Hannah, what can you do for this one?
1.314
Radians, okay? All right, pretty simple. Questions about those? One thing the guy did in the video, he brought up the theme about before you making your head explode and before you start crying and stuff like that. Is this stuff making your head explode?
No.
Not really, right? No, is other stuff we've done in class that made your head explode? A little bit, maybe?
Maybe.
A little bit. So you got a little bit of a patriotic pattern going, don't you? Okay, convert to from radians to degrees. Again, now we have pi over 6 radians, and we want to convert to degrees. Well, we're going to multiply by what?
180.
By 180 over pi. And we go ahead and we have this will cancel out this, and so we get 180 over 6 or 30 degrees. So that's going to be our conversion. Does that make sense? Pretty well. And if you look at it, if you continue here through 22, they're all pretty similar. You're all going to get things for this. I want you to go ahead and work through 22. You should be able to do those pretty readily, right? Can you do those? And then at the end of class, in a few minutes, I want to talk to you just a little bit about 23 and 24. And that'll give us a good stopping point at the end of class today. Okay, I just want to wrap up with this one right here. Here, radians to degrees. We're going to still multiply by 180 over pi, but here we have 2 radians. And the reason we know it's radians, it says convert from radians to degrees. And so we're going to cancel radians over radians, but we don't cancel out pi. So what we have is 2 times 180, or 360 over pi. And usually we don't leave it in terms just like this. So degrees, we go ahead and we get that many degrees. And just, you could say 360 over pi degrees possibly. But usually at this point, you'll just go through and get you a decimalized answer. All right. which is gonna be 114.59. Okay, and I want to call on one last person to convert 24 for us. We'll wrap that up, be a good stopping point today. 1 out of 3 chance. It'll be Carmen, all right. Okay, Carmen, what did you get for 24?
Should not have done.
You didn't do it?
She just didn't get the answer
You didn't get the answer?
on the last one.
Oh, you didn't
So
get
she
the
doesn't know
answer?
what I did.
Okay. All right, you okay, Carmen?
Seventy-four point
74.38,
forty-eight.
74.48, like this. All right. So that'd be it, right? Which answer kind of makes sense, doesn't it? Because 1 radian is about 57, so 57 degrees. So anyway,
Can you go over 20, 21, and 22? Or can you have us answer it? 'Cause, I need some
Yeah.
points. I need some points.
oh, do you? Do you? Okay, Kay, you give me, Kaylee, give me 22.
117.
117
Mhm.
degrees?
You get no points.
That's not, is that right?
I don't know.
I just kinda thought.
Yeah, I tried, but I don't know
Amy, you get
how
that?
really to
So
do
do
it.
we multiply 13 by 180 and then divide by 20?
Let me show you. We multiply by 180 over pi. So what we get is 180 over 20 simplifies to 9. So it's going to be 13 times 9, which I think when you worked out equals 117 degrees, right?
Yes.
Okay, so that's it. All right, I'll do that for you. And who else wants to give me another person again?
I'll do it.
Yeah, okay, go ahead and give me, what'd you get for this one?
140 degrees.
There too. I just didn't know that.
Okay, very good. I will do
And then I
that.
wrote
Thank
out
you
two.
for participating today.